Okay, this is a continuation of section 2.1 for MAC 1105. We were in the process of talking about how to decide whether a collection of ordered pairs in the form of a graph is a function or not. And we were talking about the vertical line test specifically. I've written off here to the side that when a function or when a graph represents an actual function, you should be able to pass a vertical line through the graph anywhere you want. It could be here, here, wherever you want, and it should not pass through the graph more than once. The minute that it cuts through the graph more than once, if the vertical line test shows a vertical line that passes through the graph more than once, then it is not a function, because at that point where the vertical line passes through the graph more than once, what you're actually finding is an x value that has two different y partners. And that is against what it takes to qualify as a function. So in this particular problem, notice that whether I pass the vertical line through the graph here or whether I pass it through the graph here, no matter where I pass it through the graph, it only passes through the graph one time. So this one does pass as a function. However, when I try to pass a vertical line through this graph, right away you see that the vertical line, I'm doing the vertical line test. Remember, you can pass it at anywhere you want through the graph as long as it's a vertical line. Notice that it cuts through once, twice, 3 times. That means at those 3 points, that x value, all of these points, all the points on a vertical line have the same x coordinate. So this x coordinate has one y partner, a different y partner here, and a different y partner here. So this fails what it takes to be a function. So this is not a function. I'm just going to abbreviate FNC for function. Here, if I pass a vertical line test, only cuts through once. If I choose to pass it through here, no matter where I pass it through, it passes the vertical line test. So because it passes the vertical line test as it did in part A and as it did in part C, this would be your reasoning why it's a function as opposed to not being a function. Here it fails the vertical line test because it passed through the vertical line touches the graph in more than one spot. Okay, if you were to do it here, you probably catch on by now that if you were to pass a vertical line anywhere through this graph, it cuts through the graph more than once. It cuts through twice. So that being the case, this fails the vertical line test, and therefore it is not a function. So this one was not a function. This one was not a function. Okay, moving on to the kind of question that they're going to ask in MyLab Math is that sometimes they'll give you a graph for some of the problems, and you'll just pass a vertical line through it and decide whether or not it passes the vertical line test or fails it, and what does that mean with respect to it being a function. Other times they'll just give you an equation, expect you to produce the actual diagram, the actual graph, and then pass a vertical line. So sometimes you'll have to go a step beyond what we did in parts A, B, C, and D and produce your own graph, which you will then use the vertical line test for. If you're going to use your calculator to assist you, you basically would just be using the calculator to get just to get the basic shape. Not going too crazy with details. And you know that in a graphing calculator, you have to have your equations solved for y. So they will verse the question like this. Does the equation, like for instance here, this would be an equation. Does the equation define y as a function of x? So really they're just saying, does this equation create a graph that represents a function or not? That's the same thing as what they're saying here. Don't forget that when you do graph, you need to get the equation isolated for y. Get y all by itself. So if you were doing that here, all you would do is move this negative 2x to the other side, at which point it would be positive 2x. So you'd be entering in your calculator. Negative 2x is not here anymore. It's over on the right, acting as a positive 2x. All you would do is go into your calculator and enter that equation. Okay, and when you enter that equation, just as a little recap of how you do that, turn it on, go to y is equal to, clear out anything that's there, and go enter your graph. So it would be 2x plus 3. There you go, right there. There's the graph. You could see it say it's just a line, so that's definitely going to pass the vertical line test. But if asked to give the graph, this would be 3, and you would be just connect those points. You can just copy them really right off of your graphing calculator. You can see where this hits. It goes right through 3, and it goes right through some of the points that I've plotted here. I just did it by hand. I saw this as the y-intercept, so that was the first point, and then I saw this as the slope. In other words, rise over run. So I did that one by hand. So I went rise 2, run 1, and I got that point. And then I went rise down 2, run -1. So this was -2 over -1. And you can see that all the points line up. So I did it by hand, but you can do it by graphing calculator. But anyway, with respect to the equation and the actual question that they're asking, does this represent a function? That's what they're they're really asking that when they say, does the equation define y as a function of x? They're just saying, is it a function? So yes, you see that if you pass a vertical line, no matter where you pass a vertical line, it could be here, it could be here, it's only going to cut through the graph once. So it passes the vertical line test, and therefore, yes, it is a function. So it can be said that y defines that the equation defines y as a function of x. This equation defines y as a function of x. Okay, some of the other equations may be a little more challenging for you to put into your graphing calculator, but they can still be put into the graphing calculator. Again, don't forget you need to solve for y, because that's the only way your calculator is going to accept the equation. So you would have here y squared plus 2x is equal to 5. You're trying to isolate for y, so you would bring the 2x to the right. That would give you y squared is equal to, you can write it like this, just like this if you want, but by the time you go and put it in the calculator, you need to get this square out of here. So taking a square root will make a square go away. And on the opposite side of the squared term, not where the squared term was, because here you're just taking the square root to make this square go away, giving yourself y. But then on the opposite side, you must report both the positive and the negative root. And you are going to actually put this into your calculator as two separate functions because of the plus or minus. So you're going to go to function 1, y1, and you'll enter the positive version of this square root. And that'll get you the positive side of the graph. And then as your second function, you're going to enter the negative version of this square root. So just with a negative, and then that same square root, 5 minus 2x. To get the entire graph, which you can then test it, use the vertical line test to answer, does this function, y equal to plus or minus square root of 5 minus 2x, does this function define y as a function of f? In other words, does the graph represent a function? So if you were going to put this in here, you would go to y is equal to, clear out whatever is there. We are putting in 5 minus 2x square root in its positive as well as negative form. Okay, there's the positive one. And then when I want to do the negative one, don't forget when you have a leading negative to grab it from down here or it'll send your calculator into an error. That's when you have a negative out front. So there's my negative, same expression, square root of 5 minus 2x, close it. Graph both of those, and you see that you end up getting a sideways parabola that cuts in right past the 2 and a little bit above the 2 on the y-axis, or right before the 2 actually. Now, these things are really not so important, what the intercepts are. For certain questions, they are, but they're not that important with respect to the type of question that you're answering right now. So it cuts in right there, and then right here. Because you just want to answer the question, does this graph represent a function? And you can see based on the examples that we've gone over thus far that this does not represent a function. And that's because when you do the vertical line test, it fails the vertical line test. The minute that you see your vertical line passes through the graph more than once, it cuts in right there, and then it passes through right there, that means it fails the vertical line test, and that means that this is not a function. So when somebody says, does this equation represent y as a function of x? No, it does not. It's not a function. So you would just say no. Okay, moving on. Same sorts of questions, only now you're trying to, instead of just looking at someone else's pre-made diagram and passing a vertical line through it, you're practicing getting your own graph. And you can do it by hand because you had plenty of problems in chapter 1, section 1.1 to be specific, where you would be given an equation. You would try various x values like -2, -1. You would try a 0. You would try various values for x and go and get the points. Or you can just use your graphing calculator. There is a table. You can go to second table and you can get the exact points that the graph runs through right on that table just by knowing how to get to the table. So if you were going to answer the question, does the equation of x plus y cubed equal to 8, does it define y as a function of x? Does the graph represent a function? So again, you can't get a graph unless you isolate your equation for y. So we're starting off with x plus y cubed is equal to 8. We're going to bring this to the other side. We're trying to isolate that y term. So 8 minus x. We're going to get rid of the cube because you can't put a y cubed in. Everything that is offered to you when it comes to graphing is just y is equal to. So we want to make this say y is equal to. So we're going to take let's see, if we want to get rid of a cube, we have to take a cube root. Just like if we want to get rid of a square, we take a square root. Want to get rid of a cube, you take a cube root. If you're going to take a cube root on this side, you have to take a cube root on this side. Now, the reason that I am not doing any of that plus or minus stuff is because this happens to be an odd root. Odd roots don't have positive and negative roots. So here, cube root of y cubed is just y, none of the plus or minus, just cube root of 8 minus x. And we will practice together how to press in cube root. Okay, so let me show you, and we'll write that here, what the keys are specifically that you would press to get your calculator to graph a cube root rather than doing your own table. Okay, so let's see. So we're going to go to y is equal to. We're going to clear out what's there. We're going to attempt to call up a cube root, which you can find under the math key. If you wanted roots any higher than cube root, then you would actually have to tell it what the index is. That's called the index, that little number sitting on what looks like a check mark. But it does have pre-made roots up to cube root. It has square roots right on the key that's right here. In the first column, you see where the square root symbol is, second function. And there's also a cube root that's ready-made You don't have to tell it what the index is. And you grab it by pressing math. Okay, so I'm going to hit the math key.